Okay, so we're going to go through the review for the Unit 2 quiz on operations, compositions, and inverses. So this first section deals primarily with observations, so add, subtract, multiply, divide. All right, so at the top we have f of x, g of x, h of x, and j of x. So all of these problems below that refer to those letters, you just have to go up and look for the function. So the first one is asking us to do f plus g of x. There's nothing in the x position, which means I'm just going to bring down the whole f function without plugging in anything. And I'm going to suggest that you are in the habit of bringing down the functions and putting them in parentheses. So this was the f function. I brought it down in parentheses. And to this I'm adding the g function, which is 5x squared plus 6x plus 1. Okay, and then I need to combine these. And when we're adding or subtracting, we are just combining like terms. So in this case, I'm going to say 5x squared has no like term, so I can just bring that down. 5x plus 6x is 11x. Okay, 1 plus 1 would be 2. So I would say this expression, 5x squared plus 11x plus 2, that is the solution, or the simplified version of f plus g of x. Okay. Problem number 2 is the same idea. Here's why it's important to put them in parentheses. Okay, when you do g minus h, the minus sign applies to everything that's in h. So let's write them down in parentheses. G minus h is going to be, let me bring down the expressions. Okay, I'm going to say 5x squared, okay, plus 6x plus 1. Okay, that's g, and then h is, okay, in parentheses, minus 3x squared minus 27. Okay, and so here's why this is really important. We need to subtract 3x. So 5x squared minus 3x squared is going to be 2x squared. Okay, 6x minus, well, there's nothing over here that pairs with 6x, so that's going to stay. And this is where you have to be careful. This is 1 minus negative 27. Well, that's like 1 plus 27. And that's going to give me 28. So that's where you really got to be careful. If you didn't put a parentheses around this, the minus sign that was originally here would look like it only goes with the 3x squared, but it actually goes with both. So again, just be in the habit of putting all of the expressions that you bring down in parentheses. Okay. So next problem, f times g. So I'm going to say 5x plus 1. That is f. Okay, and then my g function is 5x squared plus 6x plus 1. Okay. So in this case, it's asking me to multiply these expressions together. So I need to do distributing the 5x into each expression, distributing the 1. And we're going to get 6 parts that we just need to combine. So 5x times 5x squared is 25x cubed. 5x times 6x is 30x squared. Okay, 5x times 1 is 5x. And then I'm going to move on, and I'm going to do the same thing with 1. 1 times each of these is actually just going to repeat the expression. 5x squared. 1 times 6x is 6x. 1 times 1 is 1. Okay, so now I just need to look at these 6 terms and combine like terms. 25x cubed does not have other x cubes. Okay, and just for those of you that are thinking about it, we are not changing exponents. So when I add together 30x squared plus 5x squared, I'm going to get 35 from the 30 plus 5, but I am not going to add together the exponents. Exponents do not change when we add or subtract. 5x plus 6x is 11x. And then I have this plus 1, which does not have any other like terms, so I'm just going to leave that on the end, plus 1, and I would say that is my final answer. Okay. Last one is j minus g, very similar to the one that we did above it. So we're going to put j as x squared plus 2x minus 3. Okay, and I'm going to say minus, and again, notice these are in parentheses. That's really important, so I'm going to keep stressing this. Okay, because the second expression, the minus sign applies to each of these 3 parts. So when I combine like terms, I'm going to say 1x squared minus 5x squared. Well, that's negative 4x squared. 2x minus 6x. Well, that's going to be minus 4x. Negative 3 minus 1. That's going to be minus 4. Okay, you don't have to do anything. I'm sure, again, some people are thinking about this and saying, hey, I could factor out a negative 4. We're not going to do that. When we are simplifying expressions, we want it to be one term. If you were to factor out something, you would actually have 2 parts, and we don't want that. We're going to leave it exactly like this and say our solution is negative 4x squared minus 4x minus 4. Okay, each of these problems up here says complete the indicated operation, which we've done, and it also says to state the domain of the result. Okay, so when I'm looking at each of these original expressions that's at the top, I need to say what is the domain of these functions. So for linear functions like f, we're allowed to plug in anything we want for x. there is nothing that we can think about that you're not allowed to multiply by 5. So in this case, we're going to say the domain was all real numbers. Okay, and the same thing happens actually for g, h, and j. For each of these, the original function, I'm allowed to square whatever I want. I'm allowed to multiply 6 by whatever I want. I'm allowed to square whatever I want, right? So the same thing's happening in all of these. So in this case, all real numbers applies to every single one of these expressions. Okay, and what we said was when you're performing operations, if f has all real numbers and g has all real numbers, when I add together f plus g, the result also has all real numbers. So that's actually going to apply to all of these, right? This g expression was all real numbers, h was all real numbers, okay, so the result will be all real numbers. So in this case, the only time that the domain is not going to be all real numbers is if we're dividing and we need to restrict it because of the denominator. So we're going to see some of those, okay, showing up right here. So in this case, again, f, g, h, and j are still all real numbers. So I'm just going to bring that over to my next slide. Okay, so we're going to say the actual functions do not restrict anything. Okay, but in this case, when I do f over g, I'm going to look at f and say, do I need to factor f? In this case, 5x plus 1 is factored, so I'm just going to bring that down. Okay. When I look at g, g does need to be factored, so I'm going to come off to the side and I'm going to show you one time factoring this type of expression for those of you that still need help. If you're good with AC factoring, you might be able to fast forward a little bit. Okay, so in this case, I'm going to say a times c is 5, okay, and b is 6. So I'm going to say what multiplies to 5 that adds to 6. Well, in this case, I would say 5 times 1, 5 plus 1, right? So I'm going to use 5 and 1 in order to split up 6. So it's going to become 5x squared plus 5x plus 1x plus 1. Okay, so I wrote this expression again, but instead of writing 6, I wrote 5 plus 1. And then I'm going to group this first two, pull out a 5x. Okay, and then the second group, it looks like they don't have anything in common, but remember that everything has a 1. So I'm going to finish up the first group, and I'm going to say the second group has a 1 in common. Okay, and then I'm going to regroup by saying 5x plus 1, that's a factor. Okay, and then my repeating x plus 1 is the other factor. So the bottom of g, right, I took g and I factored it into these two parts. I'm going to say 5x plus 1 and x plus 1. This is the factored form of g. So this is nice because if you notice, I have a whole 5x plus 1 up here. I have a 5x plus 1 on the bottom. Be careful here. X plus 1 is in the denominator of this fraction, so x plus 1 needs to remain in the denominator. And I have nothing up here, and we did speak about this. We said that 1 is the placeholder value if everything gets canceled. So my final answer is 1 over x plus 1, but this is where I need to start fixing the domain. In my original problem after I factored, I had a 5x plus 1 and an x plus 1. Each of those is going to tell me that I am not allowed to have an x value. So in this case, if you set 5x plus 1 equal to 0 and solve, you get negative 1 over 5. When I set x plus 1 equal to 0, I get a negative 1. So each of these are a domain restriction, right? So it's really going to be these division problems that you need to be careful about when you are stating the domain. Okay, so this one does not have an all real numbers domain. It's going to be x is not allowed to be equal to negative 1/5 and negative 1. Okay, so we can do the same thing with j. I'm just going to factor j up here. It does simplify pretty nicely for us. It looks like x plus 3 and x minus 1. This is a simple factor because there's no number in front of x squared. So when I bring down the j on the bottom of number 6, I'm going to bring it down in its factored form. X plus 3 and x minus 1. Okay. H, I have actually two steps for this one, so I'm going to do the first step right here. I can just pull out a GCF of 3, and that makes it x squared minus 9. And then x squared minus 9 is a difference of perfect squares, so that's x plus 3 and x minus 3. Okay, so this actually has two steps of factoring, so be careful about that. So when I bring down h, I'm going to bring it down in its factored form. 3, x plus 3, and x minus 3. Those are my factors. So now I have that cancel happening. The x plus 3's are the same. So my final answer here, and you're more than welcome to leave this in undistributed form. You do not have to multiply the 3 back in. Okay, as I'm going to say 3 times x minus 3 over x minus 1. But again, I have two domain restrictions. The negative 3 that comes out of setting the first factor equal to 0, that's a domain restriction. And the 1 that comes out of the second one. So I'm going to say my final answer is this. Okay, but x is not allowed to be equal to negative 3 or 1. Okay, oh, I'm going to fix that. Put it back. All right, next problem. It says 3 times f of x minus 4 times j of x. So that is really just saying when you bring down when you bring down f, make sure you multiply everything by 3. right? So I'm going to bring it down 3 times, well, f of x is just the 5x plus 1, okay? And I'm going to do the same thing. This is minus 4 times j, which is x squared plus 2x minus 3, okay? So I just have to do distributing in this problem before I can combine like terms. So it's going to be 15x plus 3, okay, and negative 4x squared minus 8x plus 12. Okay, so now I can combine like terms. I have the negative 4x squared, that's my first term, no other x squareds. 15x minus 8x is going to be 7x, okay, and 3 plus 12 is going to be 15. So I would say the completely simplified version is negative 4x squared plus 7x plus 15. And again, if we're talking about domain restrictions, because I don't have any denominators like I did in problem number 5, for this one I could say it's actually everything, all real numbers. Okay, your last problem here is similar to problem number 7, okay, but they're telling us what to plug in. So they're actually saying do f of 4. So f again is still that 5x plus 1. So I'm going to say 5 times 4 plus 1, okay, minus 2 times g. Let's go up and see what g looks like. G is the 5x squared. I'm going to move my expression over real quick. Well, can't move my expression over. All right, so we'll just leave it. So I'm going to say 2 times g of negative 3 is going to be 5 times negative 3 squared plus 6 times negative 3 plus 1. I can fit that in there, okay? So I need to do some simplifying. So my first expression is going to be 5 times 4 is 20. 20 plus 1 is 21. So f of 4 is 21. And this says minus 2 times, well, negative 3 squared. Make sure you do this correctly. One of the big mistakes I see is people want to do 5 times negative 3 first and then square. Your order of operations says square first, exponents first, then multiply. So I'm going to say this is negative 3 squared, which is 9. 9 times 5 is 45. And then I can say 6 times negative 3 is negative 18. Okay, and plus 1 that I squeezed in there at the end that we need to make sure gets in here too. Okay, so again, don't do anything with this 2 yet. I need to simplify the second expression. I'm going to say 45 minus 18. 45 minus 18 looks like 29. Okay, 45 minus 18, 27. Sorry, 27 plus 1 is going to be 28. So this says 21 minus 2 times 28. All right, almost done. Well, this says 21 minus, well, 2 times 28 is 56. 21 minus 56 is negative 35. Right, so this is a problem where if you notice my answer is not an expression because I gave you specific values for x. There were no x's in my original problem, so there are not going to be any x's in my answer as well. Okay, so I don't have to state a domain restriction for this one because there was no division at all in the problem. Okay, so we got a couple more problems. Okay, number 9 and number 10, still using the same value. So f of h of 2, I'm going to go to the f function and plug in a 2. It's going to look like 5 times 2 plus 1. Okay, and that's being multiplied by h of 2, which is 3 times 2 squared minus 27. Okay, so when I simplify this one, I'm going to say that's 10 plus 1, that's 11 times, and I'm going to do the same thing with this one. 2 squared is 4 times 3 is 12. This really says 12 minus 27. Well, that's negative 15. Okay, 11 times negative 15 is negative 165, and that's the answer that you're going to give me. Okay, so these ones where I give you a value, that 2 applies to both h and to f. So I plug that into both expressions. Okay, so our last problem here is going to be a little bit of work. Okay, so we need to give ourselves some space. If you don't have any, you might want to use a separate sheet of paper. This first problem says, let's take the f function and plug in an x plus 1 and then multiply that answer by 2. So let's find out what happens. So this is going to be 2. Okay, I'm going to go to the f function and I'm going to write 5. And instead of x, they told me to plug in an x plus 1. So I'm going to say this is x plus 1. Okay, plus 1. So again, let's forget about g for a second. Let's just fix this. This says leave the 2 alone. Let's work on the inside. This says 5 times x and 5 times 1. So it's going to look like 2 times 5x plus 5 plus 1. Okay, so I can simplify that a little bit more. 2 times 5x plus 6. Okay, well, 2 times 5x plus 6 is going to be 10x plus 12. Okay, so I'm going to say that this whole big 2f of x plus 1 turns into 10x plus 12. Right? I'm going to put parentheses around that. That's my new expression. We are subtracting from that g of x plus 2. Here's my g function, so I'm going to write 5, put this in parentheses, okay, x plus 2 squared, okay, plus 6 times x plus 2 plus 1. Okay, so I took the g function, I plugged in an x plus 2 in both of the x spots. Okay, so you got to be careful again. I still have this minus 5 sitting out here. Let's leave that alone. Okay, the x plus 2 squared, again, is not just square x and square 2. I'm going to keep saying it. You have to actually do x plus 2 times x plus 2, and that is actually, if you come off to the side, I'll let you do that on your own. That is x squared plus 4x plus 4. Okay, I can distribute the 6 into the second expression. That's 6x plus 12. Okay, and then I have the plus 1 at the end. Okay, so that was a distribute. Almost done. I got one more distribute left to do. This 5x squared can be, or this 5 can be distributed into the first expression. So now it looks like 5x squared plus 20x plus 20. Okay, and I have all this other stuff too. I'm going to do one quick combine. The 6x is still there. I can do 12 plus 1. That's a 13. Okay, so make it look a little bit nicer. And now I can simplify this down to a trinomial and say that with the 10x plus 12, I'm going to actually subtract off. I only have 1x squared. That's the 5. Okay, I have a 2 of the x's. That's going to be 26x. And then I have 20 plus 13, which is 33. Okay, so I'm going to take that, okay, and this is what I need to subtract with the 10x plus 12. So I'm going to say now that I have 10x minus 26x. So let's bring down 5x squared. Okay, and here's where you got to be careful. The minus sign applies to everything in this expression, so it's not just a 5x squared, it's a minus 5x squared. Okay, so be careful with the subtraction problems that entire second expression gets all of those pieces. Now the same thing happening here. I'm going to say 10 minus 26. Well, 10 minus 26 is going to be negative 16x. 12 minus 33 looks like negative 21. Okay, so I'm going to say that right there is my final answer. Okay, and I am good to go. So I'm going to be finished up with that problem. So I'm going to stop the video. That was the first set of problems, and I'm going to start the second set of problems in the next video.